Hello, I'm Fabrizio Mariani. I work at Blue Century Cloud as a DevOps team leader, and in this video I'm going to show you how we help our customers to achieve automatic DNS record creation and SSL certificate provisioning for applications running on EKS, which is the AWS Elastic Kubernetes Service. This will be a simple walkthrough video to demonstrate how to deploy the required AWS infrastructure using Terraform from our GitHub repo and how to create a sample application to validate our solution. In case you're looking for a written and more detailed version of this guide, please visit one of the links in the description below. All right, so the first thing that you have to do is to clone the repo that contains all the Terraform scripts that will be responsible for provisioning all the required infrastructure. So let's clone the repo. Once you clone the repo, you just need to open it using your favorite code editor. In my case, it's VS Code. And you notice here that we are only relying on community-driven Terraform modules to deploy all the required infrastructure. So, for example, we will be creating a VPC from scratch using the community module. Then we will create an EKS cluster. And even the IAM roles for Cert Manager and external DNS to work will be created using submodules of the IAM module from the community. All right, so before initializing Terraform and creating the infrastructure, we need to configure a few things. The first thing will be to replace some dummy values, for example, for the hosted zone. For Cert Manager and external DNS to work, you first need to configure the IAM roles that will allow them to manage the whole Route 53 hosted zone on your behalf. And for that to happen, you need to create the IRSA. IRSA stands for IAM role for service accounts. That's the most secure way for your Kubernetes service accounts to assume an IAM role in your AWS account. So we already have all of that pre-configured using the community modules. So everything that you need to do now is to replace some dummy values here. So what I will do now is I'll go into our AWS account that we're using for the sandbox, and I will get the hosted zone ID and replace those dummy values. So I put those dummy values across all the repos on all the required resources. So all you need to do is to search recursively in your folder, and you can replace all those dummy values by a real hosted zone. So we're doing this right now. So you can get the real values. And we also need to update the domain for the sample applications that we'll use later on. And that's under our examples. So you see we have some DNS zones for our cluster issue and for our sample app. So we will also, in this case, just search recursively for like example.com and replace that by our domain that we want to deploy the apps to. All right, so everything is replaced now. So now we'll open our terminal. You will see that it's in the same folder that we were before, just inside the repo. Before you do this, you need to configure your Terraform providers. So under the providers file, you'll have to update your AWS profile that you're working on, as well as an S3 bucket and a key to hold your Terraform state. So be mindful of that. So now we'll run Terraform init. This will download all the modules from the community and configure our S3 backend. Now we'll validate to make sure that we have no syntax errors. And now we will plan. This might take a minute or two because it needs to basically show you a preview of how your infrastructure will look like. And in our case, for this tutorial, we are creating everything from scratch. Like if we are on an empty AWS account, the only pre-requirement is really to have a hosted zone where you can control the DNS, and that's it. Everything else will be created new. So you will have a brand new VPC, a brand new EKS cluster, and the Cert Manager, external DNS, and even the Nginx ingress controller will be created automatically through Terraform as well, using the community Helm charts. And here, as you can see, this is a preview of what will be created. So we create the VPC, the EKS cluster, and all requirements for our VPC. In this case, for EKS, you will notice that we are creating the endpoint as public, which is not recommended for production environments, because even though we can have a firewall, like a security group with more restricted rules, it's still not a good practice to have your Kubernetes API endpoint into a public endpoint. You should have those placed into private subnets and access through a VPN. But in this case, for the sake of this tutorial, we will keep it public and we will allow any IP to hit our Kubernetes API. So, all right. Once you have it all there, you just apply it. This will trigger a new Terraform plan. And this apply step will take about 15 up to 20 minutes, depending on the region that you are deploying the resources. And it takes this amount of time because it needs to create the VPC, and then it creates the EKS cluster, then it creates the node groups for the EKS clusters. And after those things are ready, it starts deploying the Helm releases that will create Cert Manager, external DNS, and the Nginx ingress controller. So yeah, we are okay with our plan. So we'll type yes to accept, and finally apply and create all of your infrastructure. As I told you, this will take about 15 minutes to complete, so I will pause the video and come back once all the resources are created. Okay, so after about 15 minutes, all of our infrastructure is created. So now if we want to connect to our EKS cluster, we will have to run the following command to basically create the kubeconfig, and then we need to export that kubeconfig. So you can see we are connected to our new K8s cluster. Let's see if the nodes are up and running and if all of our pods are available. There we go. It just took a little longer to respond. And let's check if we have all of our pods running. Yes, looks like we had no issues. So now that we have Cert Manager, external DNS, and the Nginx ingress controller installed and working fine, we just need to create one more prerequisite more specifically for Cert Manager, which is the cluster issuers. So under the example folder, you'll notice that I let a stage cluster issuer and a production cluster issuer there. You should use the stage one until you get all of your tests validated, so you don't hit all the limits imposed by Let's Encrypt. And since I've already validated this solution with my domain and my simple app, I'm going to straight for production, because using the staging issuer does not give us a valid certificate that I want to show you in our lab here. So here under the cluster issue, since we already updated the hosted zone with the one that we want for my lab subdomain, and we already have a correct name for the cluster issue here, we just need to apply it. So we run a kube control apply -f example cluster issuer prod, and that will take care of creating the issuer for us. Let's see if it's already validated. Yes, as you can see here, the Acme account was registered with the Acme server. Now that we have our cluster issuer created, all you need to do to test is really just deploying a sample app. In this case here, our sample app is composed by 3 different Kubernetes resources. The first one is a deployment, which is really just running an Nginx image and exporting the port 80. Then we are creating a service to expose our deployment for the rest of the cluster. And one quick note on this service is that you need to give the external DNS annotation. So external DNS will will act on your behalf and create the Route 53 record for you. So you don't have to worry about that. The main purpose of this guide is to automate as much as possible. And then for our ingress resource, we also need to give it an annotation informing what's the cluster issue that we want to use. In this case is Let's Encrypt Production. Then we need to match the same host name that we set for our service here. And since this is a basic configuration, we don't really need to configure any path or backend, just really point to the same port as our service and our container is listening to. And then for the TLS, you also need to make sure that you're using the same host name and that you're giving it a secret name. So Cert Manager can request a certificate on your behalf and store securely inside your Kubernetes cluster. So let's create our sample application now. As you can see here, we have a new pod from our deployment, and we have a new service. And also, let's check our ingress. Whenever you create an ingress, you get a new load balancer. So if you go under EC2, you see a new load balancer that external DNS should be taking care of creating your DNS records on Route 53. Since we have the annotation here for the cluster issuer, we can check the certificate objects of your cluster. And you see that we already have a new one called Simple App TLS, and this is ready. So let's just review our ingress object again, and then we can copy the host here and paste in our browser and see if we can access this website securely. And there you go. As you can see, we have our Nginx page here. And if you click on the locker there and check the connection, you will see that we have a valid certificate for our lab domain using Let's Encrypt that will be valid for 90 days. And don't worry about renewing the certificate because Cert Manager and Let's Encrypt will take care of that for you automatically. And that's pretty much it. I hope this video helped you. And if you still have any questions or if you ran into any issues deploying and configuring this infrastructure, please use the comment sections below and I will be glad to help you.